Welcome to section 7.2, applications of the normal distribution. So we just learned about the qualities of a normally distributed curve, and now we're going to be looking at how we can actually use it. So we're going to be calculating the area under the normal curve. We're going to be calculating the area under the curve. Okay, so first we're going to learn how to do this by hand, and you are more than welcome to continue to use it by hand for quizzes, exams, and homeworks. I'm also going to show you how to use the calculator, so you guys can choose whatever method you would like. But to start with, there's infinitely many normal curves because we can have infinitely many means, we can have infinitely many standard deviations. So it would be exhausting to determine the area under all the different curves. So instead, we focus on one normal curve, and that's called standardizing a normal random variable. And we do this using, drum roll, the z-score. So it's coming back. Okay, so let's draw a picture of what's going on. So let's create just any old random normal distribution. So remember, we have all of these markers. We have the inflection points. The highest point is the mean. Do our best to make it as accurate as possible. Okay, so we'll call this random variable x. And what we're going to do is we're going to come in here and we're going to use our z-score. And our z-score takes any value on this distribution and standardizes it by subtracting the mean and the standard deviation. Okay, and then we have our standard normal curve. And if you remember, the mean of our z-scores is 0, and the standard deviation is 1. Okay, so then this is our z distribution. All right, so that's how we get from one point to the other. Okay, so let's just do kind of a quick example. Let's say we had a value on this distribution to the left, our x distribution. We'll just call it like x1. We'll call it x1. And so x1 has a z-score, and we can call it z1. So x1 has a z-score, and we can map it on our z distribution. So how it works, why everything is working out, if we were to look at the area, let's say to the left of x1, that area is going to be the exact same area that is to the left of its z-score. So areas are the same. So that's why we don't have to look at all of these different normal curves. We can just look at the standard normal curve because the area is the same for a value and its corresponding z-score. Okay, and then final thing, we call this z distribution the standard normal distribution. So this is called your standard normal distribution. And sometimes in a problem, and you guys will see in your homework, it doesn't say it's on the standard normal distribution, but it will have a value of little z. And whenever we use z, we got to think standard normal distribution, which has mean 0 and standard deviation 1 all the time. Okay, so now that we understand that we can take any normal distribution, use the z-score, and then just look at our standard normal curve to get areas, let's look at an actual example. So IQ scores can be modeled by a normal distribution with mu 100 and standard deviation sigma is 15. So what percentile is an individual whose score is 120? Wait, percentile. So remember, a percentile is the proportion of the population less than or equal to a value. All right? Proportion of a population less than or equal to a value. So if we're saying less than or equal to, let's write out a couple things. We know that I'm saying proportion. Well, we just learned in section 7.1, proportion is area. So we can percentile, we're going to be looking at areas. And it's less than or equal to a value. So it's actually going to be area to the left, because going left is less than or equal to. Okay, so they're really, what percentile is an individual whose IQ score is 120? They're actually asking for the area to the left of 120. So let's write some things out. I always like to draw pictures. So let's get our pictures going. So we have 100 is the mean, 15 is your standard deviation, okay, nice little quick sketch. And then what do we have? An IQ score of 120. So maybe something like right here. And it's the percentile, and we just determined that's proportion, and it's area to the left. So our job right now is to figure out this area. And if we can figure out that area, we're going to solve the problem. Okay, so that's what our objective is. Okay, so again, what we do is we have to put this in terms of our standard normal distribution. So let's get our standard normal distribution going. And let's figure out that z-score. So we'll just call it z. You can call it z1 or just z. So the z-score of 120. We subtract the mean and divide by the standard deviation. That's the formula for z-score. And we get, if you put that in your calculator, 20 over 15, that's approximately 1.33. Okay, so that corresponds to 1.33. So 120 is one standard deviation and a third above the mean. It's 120, this is saying it's one standard deviation and a third above the mean. And we can see that. It's 15, that's one standard deviation, and 5 more is a third of 15. So it's one standard deviation and a third away. Okay, so our job, again, we're going to come in, this is our z distribution, and this is the one that we know everything about. So if we can figure out this area, then we'll have solved the problem. So now we're going to be limiting our discussion to this. And once we find this, we know the solution. Okay, so let's continue onward. So we have in the back of your textbook, you have an appendix, and I also give it to you on your exam. It's the standard normal distribution table of values. And it looks like this. This is just a chunk of it. So this table gives us the area, I'm going to highlight it, to the left of a z-score. Gives the area to the left of a z-score. So in our case, our z-score was 1.33. So area to the left, that's what we are trying to find of 1.33. This is how it's going to work. So this is our z-score. This first column is the first part of the number, and then the top row is the second decimal. So again, this first column gives us the ones place and the tenths, And then the row, the top row, gives us the hundredths place. So again, we're at 1.33, so that's going to be the column, which is right there. And then our hundredths is 3. So that's why we're choosing that column. And then where they meet is right here. So the area to the left is 0.9082. Okay, so let's go up to our problem. We just figured out this area. We just determined that this was 0.9082 using our z-score chart in the back of the textbook. And if this is 0.9082, it means this is also 0.9082. So we're able to solve the problem. So the proportion, the area to the left, is 0.9082. So how are we going to state that as a percentile? Well, we can round to the nearest percent. So 90.82%. We could say that the answer is the 91st percentile. So we just rounded to the nearest percent. And then that's your solution to this part of the problem. That's your solution. Okay, let's look at some other things. So first of all, kind of a bonus. This chart only gives us area to the left. But what if we wanted to find the area to the right? And to do that, well, we know the whole curve, the whole normal curve, has to equal, whoops, why is that taking so slow? The whole normal curve has to equal 1 under the area. Okay, so if this is what we have, and we got that this was 0.9082, then what's left over, so to the right of the z-score, it's going to be 1 minus 0.982. So even though our chart only gives us, 0.9082. Even though our chart only gives us area to the left, we can find area to the right by doing 1 minus area to the left. Okay? All right, so let's work backwards. Now suppose we wanted to find the IQ score at the 40th percentile. So again, now we're given area to the left. So again, this is saying area to the left is the 40th percentile, so write it as a decimal. It's 0.4. And we want to find the corresponding IQ score. Okay, so let's work on our z distribution first. So 0.4 is less than half. So let's say maybe somewhere right here. And we know that this area to the left is 0.4. Okay, so we want to find that z-score. We want to find that z-score. All right, well, let's look on our chart. And so area to the left is 0.4. That means we're focused on the middle part of the table. These are all the areas. The first column and the first row, those are the z-scores. And everything in here is the area. So let's look, and let's try to find 0.4. All right, so it looks like it's this row. It's getting smaller, 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 smaller still. So somewhere I would say this is the most approximated, or our best guess right here. So which one's closer to 0.40? Well, this one's 0.0013 away, and then this one is 0.0026 away. So this one's a better estimate. So let's use that, and I'll highlight it, okay? And we'll work our way out. So that corresponds to that ones and tens place and that hundreds place. So we can say that the z-score is negative 0.25. All right, and again, that's the z-score. And we're trying to find the IQ score. So we have to go back to our original distribution. And we're going to do that by using our z-score formula. Just this time we have to do a little bit of algebra. So now our z-score is negative 0.25, and we're solving for x. All right, so let's clear our fractions. Let's multiply by 15, both sides. Whoops, and I'm saying minus. Oh, wait, no, I'm right. I'm good. And then after we do that, we can add 100, and we get our corresponding z-score, which is 96.1. Okay, so we could say as an answer, suppose we wanted to find the IQ at the 40th percentile, we always like to answer the question. This is just a bunch of scratch work to help us form our thoughts, but we could say that an IQ score of 96.1 is the 40th percentile. All right, so let's look at our calculator instructions. I am actually going to go over this in a separate video. I'll be typing out your instructions and showing you on the calculator. Before I do that, the last thing I wanted to write out for you guys is Z alpha. We're going to be using this a lot in chapters 9 and 10 and so on. Z alpha, again, get in the habit when you see Z, think standard normal curve. Okay, so again, that automatically means mean of 0 and standard deviation 1. Okay, so Z alpha is area to the right of a value. So let's do this right here. Let's say we're calling this Z alpha on our Z distribution. So Z alpha, we're thinking area to the right. And the area to the right is alpha. So for Z alpha, the area to the right is alpha. So one of the ones we use often when we're doing our inferential statistics, let me just draw out something really quick, is 0.05. And you can remember that's 2 standard deviations away. Oh no, that's not true. It's a little bit different than 2 standard deviations away. We'll do the exact calculation later. But Z sub alpha, now alpha is 0.05. So that means the area to the right is 0.05. Okay, and then we'll finish up the rest in our calculator video. Stop.